Hey everybody, and welcome to this video on special products of binomials. So let's get the show on the road. Alright, so now we have the tools in our arsenal to multiply any polynomials that come our way. However, there will be some special cases where it'll be nice to be able to look at a pair of polynomials and immediately know what the product is going to be. The first such case is when we square a binomial. And if you look at each of the examples in front of you, you'll notice that each features a binomial, a polynomial with two terms, being multiplied by itself. So what I would like you to do is to pause the video and please make your way through these and see if you start to notice a pattern arising. If you do, maybe even try to predict some of the products before actually carrying out the multiplication. Hopefully we can find that there's a pattern that applies every time we square a binomial, in which case we'll be at liberty to use it in the future and not need to multiply out the long way. Alright, so why don't you pause the video, go ahead and take care of them. Alright, now to see if we can find a pattern. Now note, in each of these cases, we were multiplying a binomial by a binomial, and there were 4 steps of multiplication. And I first want to focus on the first step of multiplication, which always involved taking the first term of the first binomial and multiplying it by the first term of the second binomial. Of course, those two terms are exactly the same, and so we always get the square of the first term in our product. And I want you to pause the video and actually confirm that in each of these products, you find the square of the first term in each of the original binomials. Now I want to turn our attention to the fourth and final step of multiplication in each of these cases. That last step of multiplication always involved taking the second term of the first binomial and multiplying it by the second term of the second binomial. Of course, those two terms are the same, and so you get that second term squared in each of the products. And again, I'd like you to pause the video and confirm that in every single one of these products, you found the square of the second term of the original binomials. Alright, so when we square a binomial, we get the first term squared in our product, and we get the second term squared in our product. But there's always this extra term in the middle. And where does that come from? Well, it comes from the second and third steps of those 4 steps of multiplication we did every time. And what ends up happening, you end up multiplying the first term of the binomial by the second term of the binomial twice. And that's what accounts for that middle term every single time. So, to summarize, whenever we multiply a binomial by itself, you get the first term squared, you get the second term squared, but you also get twice the first term times the second term. And again, I urge you to confirm this by pausing the video, picking a few examples from the ones we just did, and seeing that this is absolutely the case. Now we can generalize this if you'd like. And what we'd say is, in general, a plus b quantity squared is going to be a squared plus 2ab plus b squared. And you can confirm this against all of the binomials of that form that we looked at. You could also say that, in general, a minus b squared will always be a squared minus 2ab plus b squared. Extremely similar to the other form, except this middle term has a subtraction sign in front of it instead of addition. And you could check this against all of these binomials of that form that we looked at. Now these give us some really powerful tools so we can simply look at a binomial being squared and immediately know what the product is. Now, there's nothing wrong with going ahead and multiplying it out what I'll call the long way. But it is nice to have this neat little trick so we can save a little time when we're faced with a special situation when we're squaring a binomial. Alright, and here are 4 quick examples to try where we've got a binomial being squared. Again, there's nothing wrong with taking your time, writing it out, and doing it what I'll call the long way. It's probably the better way to prevent yourself from making any errors. But it's good to practice this nice little generalization we just made so you can rattle through these binomial squares really quickly. Either way, why don't you pause the video, take care of this multiplication, then play the video, and I'll walk you through it. Alright, so for this first example, I know that when we square a plus 6, we're going to get an a squared. We're also going to get a 36 at the end. But in the middle, we're going to get twice a times 6. So we're going to get twice 6a, we're going to get 12a. And if you multiply this out the long way, that's exactly the same thing you'll get. It's just nice to be able to do this a little bit more quickly. In our second example, m minus 9 quantity squared, I know we're going to get an m squared. I know we're going to get a negative 9 quantity squared, which is 81. And I know we're going to get twice m times negative 9. Well, m times negative 9 is negative 9m, and twice that is negative 18m. Boom. Again, could have done it out the long way, just nice to be able to do this a little bit more quickly. In 3 minus 2d quantity squared, I know I'm going to get a 3 squared. I know we're going to get a 9. I know we're going to get a negative 2d quantity squared. I know we're going to get a 4d squared. And I know that in the middle, we're going to get twice 3 times negative 2d. Well, 3 times negative 2d is negative 6d, and twice that is negative 12d. Now, of course, we want to end up putting our polynomial in standard form to finish, so we're going to write this as 4d squared minus 12d plus 9. And in our last example, which involves a fraction, same exact strategy. I know we're going to end up with an h squared. I know we're going to have a negative 5/6 quantity squared, which is positive 25/36. And I know that in the middle, we're going to end up with twice h times negative 5/6. Well, h times negative 5/6 is negative 5/6h. And twice that is going to be negative 10/6h. So we end up with h squared minus 10/6h plus 25/36. We can reduce that negative 10/6 to h squared minus 5/3 h plus 25/36. All right, the second special product we're going to be looking at today is when, instead of multiplying a binomial by itself, we'll be multiplying 2 binomials that look almost identical, except one has addition between the 2 terms and the other has subtraction. So what I'd like you to do is to make your way through the first 6 problems you see in front of you. And like last time, as you make your way through the examples, see if you notice a pattern arising. And if you start seeing one, start trying to anticipate what the products are going to be before carrying out the multiplication. Alright, why don't you pause the video and take care of them. Alright, time to find a pattern. Again, in each of these cases, we multiplied a binomial by a binomial. So there are 4 steps of multiplication. What I'd like to do is first concentrate on that first step of multiplication, which is actually the exact same as it was in our previous special case. In every example, we multiplied the first term of the first binomial by the first term of the second binomial. Since they happen to be the same, we get that first term squared in our product. And I urge you to pause the video and confirm that in each of these products, we find the square of the first term of our original 2 binomials. Now I want to take a look at the second and third steps of these 4 steps of multiplication in each case. And note that in the second and third steps of every single one of these examples, the 2 resulting products add to 0. They cancel out, if you will. And so they don't show up in our final product. If we take a look at our last step in these 4 steps of multiplication, we always end up with something like positive 4 times negative 4, or negative 5 times positive 5, or positive 3x times negative 3x, or negative 2 times positive 2, or positive 7b to the third times negative 7b to the third, or positive 6 times negative 6. All in all, we end up subtracting the perfect square of that second term of each of those binomials. And I urge you to confirm that in every one of these products, we end up with subtracting the perfect square of the second term of each of those original binomials. And so we can generalize that if we ever have a special case where we multiply the binomial a plus b times the binomial a minus b, we end up with simply a squared minus b squared. And that's it. It's rather clean and pretty nice. So armed with this new tool, I urge you, why don't you pause the video and take care of these next 8 multiplication problems. You are welcome to go about doing it the long way, no harm in that, but I also urge you to try using this generalization to make your way through these problems quickly, but yet accurately. All right, why don't you pause the video and take care of them. All right, I hope that went well for you. A couple of notes. In this second part, I went ahead and I made sure all my products were nicely in standard form when I was done. I know I didn't do that originally, I just did so before to really emphasize that point of the generalization we were trying to make. And I also want to point out, for this 5th and 6th example, we had some weird square roots going on. But notice the pattern remained. By definition, the square root of 2 multiplied by itself is 2. And that's why we got b squared minus the square root of 2 squared, or b squared minus 2. And in the 6th example, the square root of 5 squared, by definition, is 5. And that's why we got m squared, or m to the 4th, minus the square root of 5 squared, or 5. All right, guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.